Hello. Hi, everybody. It's a Wednesday, and we're live. Why is that? I'm not alone here today, but thank you so much for coming. Hello, everyone in chat. Brendan's here. Kevin's here. Ooh. Gwynexburr is here. Ooh, let me make that a little bigger. There we go. You can read that. There we go. Raul XFD is here. Let's see. Cloud Plumber. Ooh, that's a fun name. I like that handle. Scott, what's up? Everybody's in chat. Raymond's here. Corey's here. All right. So if you're late, you're going to have to catch up. We're getting rolling because this is going to be awesome, and we got a bunch to get through. So welcome my special guest, Eric Smalling. I think this is first time on the show? First time on the show?
I think it might be.
Okay.
Officially. I've been in the chat a lot.
Yeah, Eric hangs out in here. He has privileges on this channel. He can put links in chat and everything. He's very special. But sadly, Normal is not here today, and in his attempted replacement is Eric. Eric and I go way back. He used to work at Docker. He used to work at Sneak. He has been infrastructure and security stuff for so long. We see each other at Docker cons. He's a part of the High Fivers group. We're like, I don't know, brothers from another mother. I mean, we get along. We like old fashions. We hang out at the conference booths together. So, and conferences are really how we hang out now. Like, this is basically the only time we see each other. And it's just KubeCon because DockerCon's no more. And so welcome to the whatever this thing is. We want to call it a stream, an event.
Thank you very much. I like tequila old fashions, though.
Clarify tequila old fashions.
Wants to buy me a drink? That's my thing.
Is that like old cactus? Does it need to be a different name?
It's what it sounds like. It's bitters and tequila and a bunch of sugar.
Yeah, makes it more delicious. Well, I'm so glad. So if you did not get all my emails, how did you get here? But if you did get all the emails, I hopefully that you're here. You're anticipating something that you've maybe not understood, or maybe hoping that you have a better solution to. And that's what we've been working for weeks on. So Eric and I, for weeks now, have been meeting, trying to figure out how to talk about Dockerfile migrations and the automation of not only getting onto a smaller base image. We're going to call these base images. Those are all the images you depend on. Python, Node. We're not going to talk so much about like Postgres or Nginx and others, I think, but those are definitely part of the conversation. But these images that you're depending on, whether it's infrastructure images or images that are the base layers of your apps, they matter. We all know they matter, and they're always harder and more complex than we really wished that they were, I think. Sometimes, as awesome as I love Docker and Docker files, I keep thinking, man, there's got to be an easier way to some of this stuff. It's very challenging. If this was all easy, Eric and I would not need to be here. So
That's
our
true.
plan today is we're going to walk through our desire to have automation to help you bring your CVE count down, regardless of what images you're using, and how automation can help you essentially be one PR approval away from dropping it, at least hopefully a few CVEs, by updating your images more quickly. And this isn't just about tags. We're going to talk about the differences between tags and digest and how that can get complicated. And obviously what you choose for your base image matters. Chainguard makes these 0 CVE images. We'll talk more about that later. You've got all of the Docker Hub stuff that we've had for over a decade. And there's choices there that largely haven't changed. I feel like those choices on the official images or a couple hundred images, they haven't really changed a lot. Of course, some people decide to just build their own custom images for Postgres or for Node.js or Python by bundling on top of their favorite distribution. And hopefully the things we're going to talk about, we've got some pictures to show because we were trying to solve these ideas in our head, and We made chicken scratch drawings of them, and we will talk about that. And we're going to show off a repo of all the GitHub actions and some of the documentation we're trying to create around this. This is a living thing. So I want you to know that we got working on this, and I came up with the term silent rebuilds for what I consider this problem to be. And my hope is the repo we're going to present to you today is a living thing that we can add some more GitHub actions to. I'm actually working on Claude and I are working on some PRs to improve some of the reporting and CVE analysis stuff. So enough with me talking about what we're going to talk about. Let's frame this problem, Eric.
Yep.
You and I started a couple weeks ago talking about how to slim down our images, and we're going to do a demo of that later. But we were talking about image base layer choices, Debian, Alpine, Ubuntu, Wolfie, which is made by Chainguard. And at some point, I got distracted. Maybe this was my fault. I got distracted by how do we automate ourselves to the point that we're never more than one upstream build, we're going to call it, upstream image build, never more than one away from what your provider is providing you. Because we've all got base images, and whether it's Docker Hub or Google Cloud or Chainguard or any other big company that makes images of big open source software and open source languages, they take it from there.
Well, there's contention, right? So you could go latest or floating, to a floating, Python 3.12 or something, and just continually, if you're a, full-on microservice deploy 18 times a day, maybe that's what you do. But most people I work with, so just so you know, I work for Chainguard. I work with our customers, helping them migrate. So I see a wide variety of things, mostly in enterprise space. And most people aren't going to be on a floating build because they need to be able to say, I want to know what that base image or what I'm pulling. I want to know what it is every time. So you need to pin to something. So we've talked, Bret and I've been talking. There's the idea of a pendulum swing, right? You can pendulum swing all the way to as far one side as you can go is latest, and just rebuild, and YOLO. Get whatever you're going to get. That will keep you, on the latest, right? As long as you're building. But the pendulum swing on the other side is I need completely deterministic builds. I need to be able to say, I know what I'm getting, and what's going to come out of this thing is that plus my stuff. Yeah. Well, the way to do that would be to pin to maybe a semver, but is that really it or not? We're going to get into that. But the digest of the image is the most specific thing. It can't change. Once you have a digest, it's math, right? You can't change the image, or the pin would change. But now you're stuck to that, right?
And I was trying to, and you were describing that. I was trying earlier this week. I was trying to draw a diagram of a pendulum, and we have deterministic on one side and freshest, latest, most up to date, automated deployments of images on one side. And I realized my drawing sucks, so I asked ChatGPT for something better. And the idea here is that a lot of us are choosing either extremely deterministic, right? Like we're pinning to SHAs in everything we can. We're tags don't matter to us as much as pinning to that digest every single time. We're going to show how to do that, actually, by the way, too. And then that creates this whole process. And then your tools might not be aware of this underlying silent rebuilds problem that I'm claiming that's the name of it. And then there's that. And then you see people that are just like pinning to major versions, and they don't really care the underlying actual build that they're using, which means they potentially might have a different build in test than what's actually in production servers, even though it's got the same tag. I know that's happening out there. We just have no industry data to tell you how often that's happening. But I'm sure that if you don't pin your digests exclusively on everything you're doing, you're eventually going to end up with tests being on different images than in production, or you're going to have two production clusters where they're actually different builds, but the same tag. There's I don't think you'd have, at least in Kubernetes and Docker and Swarm and stuff like that, you wouldn't technically have the two different images running in the same cluster, because in the background it's pretty cool. These things actually all tend to look for the digest and then pin to that on your behalf. It's kind of like DNS. It's like the computer actually doesn't care about the tag. It cares more about the SHA hash, and it's always going to rely on the SHA hash in a Kubernetes cluster or Docker. So my goal with this is, if we explain kind of the digest process, my goal is that we're not taking this pendulum and trying to find the middle. We're basically trying to bring the sides together. We're going to try to hard pin and make sure that everything in every release, in every PR, and every repo is pinned to the digest exactly the one we want, the cryptographically almost completely guaranteed way to ensure every bit is the same. And at the same time, we're going to ensure that every upstream change, including a random rebuild of your node upstream image or whatever it might be, we're going to make sure that that shows up as another PR so that you didn't miss a thing. And that the most work you have to do is simply review the change in the PR, which in most of these cases, Eric and I are going to go through, it's just a SHA hash change. And so then you have to have other tooling to tell you, well, what's really changed here, if you care. Which is what Eric and I were doing a lot of this week. We were looking at digest, trying to understand what changes and what doesn't happen, the difference between different registries and how Chainguard is different from Docker Hub. And so can you lead us off with, let's talk about real quick, just pick whether it's Python or Node, and we talk about Symver, how tags relate to the digest. Let's just go through that real quick to make sure everybody's, if you're not pinning images today, this may be like a brand new concept to you. But if you're not pinning to the SHA digest, the SHA-256 digest, this is a kind of like a new thing for you. So kick us off for that.
So when you look at an image, we all know that a digest is a cryptographic hash of the contents of the image and its metadata and whatever. If anything changes, that's going to change. Yeah. Tags are just pointers to them, right? So if I've got node 24.0.0, that's going to be a pointer to the digest of the if you're using Dockerfile of that image. Do you want me to show the thing we were talking about, the timeline I built on this?
Yes, I was just sipping coffee that everyone got to enjoy.
Let me convince Zoom to do that.
We can also look at just Docker files directly, or you could bring up Mastodon. We're going to talk about the Mastodon project as an example along this path we're going to take you on, so that you have a real world image, because Mastodon, the social networking platform, is completely open source. So, and you can run them yourself. And it's a big monolith app. So it's really complicated. It's got lots of image dependencies, and it's a good example for us. Let me check chat real quick.
So while he's doing that,
I don't know who's commenting on which shirt, but one of us has a great shirt.
This is a corporate shirt. It was for our Austin events we had last year. So it's an octopus holding a guitar because it's Austin.
Because that's totally exactly what they do. So Parasha 3 is saying, I do not fully understand the difference between digest and tag. So let's go through that real quick. Let's just look at a Dockerfile. Let me pull up a Dockerfile real quick. The only thing in the Dockerfile is going to be one line. So real quick, when you're in a Dockerfile or a Kubernetes YAML or a Helm chart or a compose file or anything that you need to point to some other image to start from or to deploy. You might be in Argo CD, you might be in Kubernetes or customized YAML. And in Docker files, we know that there's the from. So this is a Docker Hub image. It's technically probably like Docker IO /something/node. But if you're using Docker Engine, you get a little shorthand there, right? So we know this is a node image. It's showing the tag, and I've fully Symver pinned this tag. I've down to the patch level. I've chosen this image. If we go back, I can actually show like I made a bunch of contrived little examples of different images, and how to do it. But here's one where we're actually pinning to the digest. And like Eric said, every time you rebuild an image, even if any of the metadata changes, or even if a file date changes, not just the file itself, but just the date changes, most of the time, in almost every case, even if you're trying to be very deterministic, meaning that you want exactly the image build every time to be exactly the same, you will often end up with a different digest. It's actually very hard to ensure that the digest is the same in images. So if you're trying to get to that utopia, Chainguard's figured it out, but very few of us are able to do this on our own. In this case, what's happening is we have three main parts actually of the image. We are defining, this is technically the repo it's coming from on Docker Hub, and this is the tag, but then we're adding an at SHA-256 and this line. This is that cryptographic hash that's happening at the end of every image build. It's always been happening since the dawn of time. Each layer has its own cryptographic hash. Each image has its own hash. There's actually metadata we can get into. There's a ton of hashes all the way down. Like things are cryptographically guaranteed so that we can ensure that the layers we're getting are exactly the layer we want, and the image we're getting is exactly, we call it content addressable. So in this case, I'm not just saying, give me node 24. I'm saying, giving me this exact build of node 24. And we do this for NPM, for gems, for any application where you have dependencies and you're cryptographically locking to the exact git commit or build of that binary or those libraries. You're doing the same thing all over your other apps. We're just doing this in Docker now. And this has been an increasingly gold standard. Like we're to the point in the industry where this is something you need to be doing all the time. You need to be doing this as much as possible, where you're pinning to the exact build, because this tag is mutable. This part is immutable. I mean, there is such a thing as SHA collisions, but that's a theoretical thing that doesn't happen really, usually. And this thing is hard to reproduce. You have to have exactly the same bits to make that tag there, or that digest. But this tag, I can assign it to whatever digest I feel like. I could assign that to Postgres if I felt like for a moment and hurt the internet. Yeah. So this is just a made up human string of characters and letters and numbers. So it doesn't really mean anything to the machine. And in this case, when you do this, as far as I know, all container runtimes, as soon as I throw the SHA hash in, it's technically ignoring that tag, right?
You could put any string you wanted there for the tag. If you put a SHA hash on it, it's going to go get it from the SHA hash, because it's kind of like it's a name lookup, right? It's saying, what is that pointing at? Oh, there's the SHA, there's the digest, as they call it. Go get it, and then the work of getting the layers and all that. Usually when you're pinning this the first time, at least for me, when I pinned it that first time and I tried this, I thought, well, what if those are conflict? What if the tag doesn't meet the digest? Does Docker care? And it turns out, no, absolutely, it does not care. It will ignore it. In all cases, it ignores this. This is for us. This is so that humans can know, we were intending for this to be tag 24, but it turns out that tag probably has more than one digest because it's been rebuilt for various reasons. And this is the silent rebuild problem. So I think, can you pull up the markdown first? I'll share your screen. Okay. Sure.
Or do you have that ready?
I can.
Or I can bring up the markdown.
If you've got it, bring it up.
Yeah. Just because I think before we look at yours, what was yours? Were we going to do Node or Python?
I was going to do Node. I don't have a timeline for Python.
Okay. So we've got this repo to share with you. And in fact, let me just share it with you. Copy link. Yeah. So this is the silent rebuilds repo. So we're going to try to store a lot of the documentation, the GitHub action examples, some example Docker files, and some of this stuff. But what Eric has been spending a week or more doing, he spent this, I think you spent a week on Mastodon, and then you spent a week studying data of historic, like you were the national archivist for image digest correlations.
Finding tag history of digest for tags is not something that Docker Hub provides. Most registries don't. Chainguards does, but it's because we have a special case, and we actually had an extension to do it. So trying to find out what was, whatever tag at some point in time in the past, it's not trivial.
Yeah, and so what we did in order to prove our point, which has been a little bit of a roller coaster for a couple of weeks, because for a couple of days I actually wasn't sure this was true. I was sure it was true, then I wasn't sure it was true, and then Eric's like, no, it's definitely true. And so what we did was we put together some Markdown and some HTML to describe this problem visually. And what we're looking at is the Node Docker Hub official image. Now we should say, Docker Hub has been providing these official images of open source projects for over a decade for completely free for the entire internet. I suspect, much like DNS, if we were not able to get these from Docker Hub, a significant, decent little portion of the internet would go down. So if you didn't know how these are built, in the background, we're not going to dive into it unless you have questions. Of course, we're taking questions the entire time here. But if we told you that you went and got the Node 24 image, Node 24.3.2, all the way down to the exact Simver. If we told you if you ran that today and then you ran it in a week, and it might actually be a different build in a week, you might not realize that. And I didn't know that for years. And I think you even mentioned the same, that we both went for years without realizing that changes happen on Docker Hub without like a new tag version.
Yeah, and to be fair, it doesn't happen a lot in the official images, but it can and it does.
Yeah, so Eric pulled together these stats, and what this is showing is for a very specific tag of Node. So in this case, like 23.11.0. So if you were to use that tag in your image in a Dockerfile, you would get 23.11.0. But on a certain day, you're going to get a different build. And that he correlated how many builds per tag. And remember, each build is its own digest. So how many builds that were published on Docker Hub for that tag. So these tags are mutable, newsflash. But every time this gets rebuilt and pushed, that tag gets pinned to a different build, a different digest. And if you did a Docker pull or a Kubernetes deploy, kube control deploy, you're going to get, if you didn't pin to this SHA hash, you're going to get a different build of the image. Now, 99.99% of the time, this is usually a good thing. It's not going to usually break something. It's not technically a new version of Node at all, but it might be a new version of an OpenSSL dependency. It might be that a core OS library was swapped out. It just kind of depends, and Eric and I went through this. You can probably speak better to this, but we went through it for a week looking at Node and Python and Postgres and just different, and Nginx and different open source projects. And a lot of this really comes down to the nuance of projects. For the Node one, I can tell you, I can speak to the Node one a little bit, that the way that Node image happens is through the Node organization, the Node.js organization. They have an open source repo where they manage all the Docker files that build the official images. And when they're ready, they will then push a PR to the Docker library that tells Docker, hey, please rebuild and push our image to Docker Hub to update these tags. And sometimes it's updating, these PRs might update 15 tags at the same time. It just depends on what changes they're doing in the repo and what versions of Node it affects. And in a lot of cases, and this I think is true for all of us, and then I'm going to hand it over to you for thoughts, but in a lot of cases, this is an imperfect science. We can't say that these upstream images are only changing for CVEs or particular improvements. It might be a rebuild that nothing changed. And it just has to go with the way that all our CIs work. I mean, these open source projects and Docker Hub CIs, they're imperfect. So they might rebuild images because something changed in the repo, but it didn't actually affect the image. The CI wasn't smart enough to know that. It still rebuilt the image anyway and made a new digest and then shipped it to Docker Hub for no reason. So I think one thing's, would you agree with me, Eric, that like we're not saying these have different files in them and that they're better?
No, not
Always.
necessarily. Right.
Yeah.
Right.
But you did, so plot twist, you did this, you did a gripe scan of each one of these to show off versions, and I'm going to put it on your screen because you had
the one you're looking at right now, though, that was as of the day I made that report. So those numbers are pretty high because that's an old image. So CVEs, they build up over time if you're not refreshing.
Oh, right, because these are old, right? Because this is
that build is, I don't see the date, but that's
that was 6 months ago, 5 months ago.
Yeah. So there's that, since that's an old build, it's not getting new builds of anything anymore. It's collecting CVE. So that's as of a few days ago. It had 40 criticals. So yikes. Yeah, if you're on that old version of Node right now, get off it, please.
Yeah. By the way, if you see the drawing tool that I'm using, it's Excalidraw. Go check it out. It's free. I'm looking at. I'm catching up on chat. You'll know his
drawings from mine because mine are very, very simplistic because I'm not an artist like Bret. So you've got my screen up. I can't see the feed right now. So what we're looking here is left and right. So on the right is, Chainguard has a page where we have all of our images. You can go to images.chainguard.dev. And I just searched for Node, and then I went into the comparison tab on the right. And you're seeing, and I put 6 months down. So I'm saying, show me Node latest, which is 24 as of when I ran that, or when this was pulled. And it's showing for this last 6 months, the CVE counts for the upstream Node latest and the Chainguard Node latest. And on the right is a timeline view of the same data, but put into, so we can see what was actually being scanned. The dates in the middle, as you go down, get older and older. So I went back 6 months. So you got, in May. So I'm going to look at the left first only. This is the upstream Docker Hub Node latest, or Node 24. And you can see the tag, the version of Node, the tag that's on it, as well as the digest. And then this is the counts that would match, if you hovered over this, you could see the CVE counts. 24.0 had a build on May 8th. 24.01 got built on May 9th, and its first hash was Charlie 2619 blah, blah, blah. And these are truncated, obviously. It got another build on the 14th, and 149 Alpha O Baker is also 24.01. Or it became, 24.01 became that, is the way to think about it. So the pointer that is 24.01 moved. Now there's many tags, right? There's 24.01-Trixie, there's all these different tags. A rebuild happened, though, that moved the Semver 24.01 forward. So if you were pinning to just a Semver, and you built on May 10th, and then you built again on May 15th, you would get a different base. Now, is that base, different? Is the file system different? I don't know. We'd have to go look at it. Probably not much, if anything. A lot of these are config changes. These are small things. But I did find, and I don't have it, looking around, I saw one, I think it was one of the Python ones, I saw, a static library change, a .a change in the between two. Didn't have time to go dig down and find out why, but that can happen. So you see 24.02, the same thing happened here on the 22nd of May and the 25th of May. And you can scroll down, you can see all the different times that everything that's the same color is the same Semver tag. So different hashes, 24.20 got 3 of them over a span of June 9th to June 23rd, and so forth.
Yeah, and this, now, by the way, the HTML he's looking at is in the repo that I shared, which I think I will share again. So we're trying to make all this training information, everything open source. So we're just storing it all in the single repo. And the real point here is that because we have a great question that's related to this. Kapor is saying, But normally they would rebuild the same tag because they're patching this image, remove some security issues, right? So this is good, I think. So you can't assume what the reason is for the update. In general, a rebuild of a tag in general does not increase your CVE count, but there's no guarantee it lowers it. And it's not always for security issues. Like Eric was looking through the vulnerabilities, and we saw some that stayed. A lot of them stayed the same. The CVE count was the same. So we don't know the reason for the rebuild. If you were to go looking at the open source repos, you would eventually end up, like if you were just to pick on Node, you would eventually pick, let's see, go to Node.js organization, and then I'm going to switch to my screen real quick just to show. And then one of these are probably, I think it's called Node Docker. Docker Node. Okay, so this is the official image that when you use Node from Docker Hub, this is where it's built. Or at least this is where it's built. And then they do a PR to the official, what's called the Docker library repo that gets it into Docker Hub. At least that's how I believe it works. But if you go through here and you look at their pull request where these images are built, because I'm pretty sure these are all built using GitHub Actions, these are all causing a rebuild of an image, but they're like sometimes it's a documentation or a README or it's nothing related, or it's official support for maybe there's like a Windows change, but it doesn't. But the Linux is a rebuild anyway, and that's largely due we mostly all have CIs that are non-deterministic, meaning the CI before it runs can't figure out if it is like the CIs are not usually smart enough to go, ooh, did that file change? Is that going to affect the image that's the output artifact of me? Should I rebuild or not? Right? Like they're not. It's usually just like, hey, there's a change in the repo. Let me go rebuild. It's very it's a pretty sophisticated setup when you can like see basically almost like build ignore lists of file locations that if they change, don't care. Because you might have just changed a linter config, and that causes an image rebuild, which changes no files in the image, which then changes the upstream tag. But you should still be on that version, because if you don't know what the change was for, then you have to assume every new digest is important. You have to assume that digest is better than the one you're running, because it's hopefully reduced to CVE or something, but we don't know. So you have to assume you need to be on it. So the premise here that Eric and I we're claiming is that if you are just pinning to tags, or if you're pinning to a digest, but your automation doesn't account for these new digests for the tag, then you're out of date. And what that means is that, sure, you could be making your own custom bespoke versions of Node if you wanted to, but if you wanted to be on always the latest build, the freshest thing from Docker Hub or Chainguard or any other image provider, you have to have these automations in place to account for those moving digests, for those tags that move around to the newest digest. So you have to start from that point of view, and that's what this repo is going to do for you. It's not necessarily a panacea. It's not just going to magically solve your problems. But we're trying to give you documentation and examples so that you understand the problem, understand that there's pretty easy solutions. We're going to talk about Dependabot, Renovate, and Digestabot, 3 tools that can help you solve this problem. And a lot of people are using those tools, but they don't realize that these digests are being rebuilt more often than the tags themselves. And so they need in their automation, it might be every day. Eric, you're saying that Chainguard rebuilds every day and checks whether or not it's different or not. Like, how does that work if you're using Chainguard?
So just, I want to respect time here, but the quick thing, this is exasperated with Chainguard because we rebuild our images daily. Everything in a Chainguard image is built from source. So any project, everything we build it into APK package, like Alpine type packages, even though we're not Alpine. Anything in the source code repositories that those APKs are built on triggers a rebuild of that package. So OpenSSL or BusyBox or Bash or Nginx mainline or whatever, if anything happens in the upstream, that's going to get bumped. And there are other things that can cause it to get rebuilt, but that's the usuals. So we do that all the time as they happen. Get release happens, we see it, we rebuild it, and then every day the images all rebuild. We build all the images every day, and we have a very deterministic tool called APKO that does this. And if any APK changed, or if any metadata for the image changed, we will produce a new digest and a new build goes out. And if the changes don't involve the main package, the thing that the thing is named for, like Node or Nginx, then that tag's not gonna, we're not gonna put a new tag out. The tag just moves to the new digest. And just, the APKO tool is deterministic, so we can actually rebuild every day. And if none of the APK has changed and none of the we didn't change any metadata aside from that, the digest won't change because it's going to build exactly the same thing every day. But yeah, because of that, our customers have to deal with that a lot. You have to know that the digests are going to move on you, and if you want to stay on the latest of a given anything, you need to watch that and update your pinning. This isn't really that much different than if you're pinning to a semver, because if you're pinning to 2402, and even if that project never rebuilt that digest, you really need to get on 2203 or 2204 when those things come out. Otherwise, when 2203 comes out, 2202 will start having CVEs because it's not getting rebuilt anymore because the project has moved forward.
Yeah,
so
and that's an important
part. The
part.
problem is just much more granular.
Yeah, it's the important part I wanted to mention was that one of the revelations for me in the last 10 years is that when you're using a dozen, 20, 30 different open source repositories, you've got Redis, you've got Postgres, you've got Nginx, you've got Node, you've got Python in there, you've got, you have some Java in there, you have all these things, you're using all these base images, and how long a tag is getting rebuilt, basically supported, when it's moved to the next version, how many versions back, how often these are all very project specific. So Eric and I couldn't find a consistency across the ecosystem. We all can't even agree on how to version things. I mean, Postgres patches in the minor version, Node.js patches in the patch version. You talked about how Python is different. And so when you look at their support policies, whether they have LTEs versus mainlines versus stable, all of these things actually affect how long tags are rebuilt. And so we can't even say across the industry, this is the standard for how long how long should your image be in production before you're checking for a new version? That's kind of to me, a little old thinking of 5 years ago, maybe 7 years ago, we were, those of us are sort of the more leading edge companies, we were rebuilt, we started coming up with these rules of your images on production should always be less than 30 days old or less than 2 weeks old. And the more hardcore you got, the more you made sure. But we were largely just blindly, at least in the organizations I was working with, we would just sort of brute force it. We were sort of cron pushing updated builds for no particular reason. We just were well, let's rebuild and push just in case. But we've got better tooling nowadays. We don't necessarily need to just daily push everything to prod all at the same time. We can detect these digests. We can only do something in production when a digest changes. And in a minute, we can show off those GitHub Actions real quick. Yep. Anything else you wanted to show on the HTML or the diagrams before we move on?
No, I think we're time is against us, so let's keep going. I want to make sure we get to the meat.
Well, this all gets edited in post anyway, so
yeah,
everybody's here for the live recording version. But the repo that we're gonna keep going through. Oh, this is not the repo. This is the node repo we were talking about. But over here in the repo example we're giving, we're going to end up with a set of workflows that are going to help us from humans ever having to manually check upstream. That, I don't want to have to go to Docker Hub to find out if there's a new version of anything. Or I don't want to go to Chainguard to find out if there's any new version of a Chainguard image. I want this fully automated. And what's funny is when I fully automated this first time, a week ago, and I've got a lot of examples on this. If you didn't know my repos, if you haven't looked at my open source, I have tons of GitHub Action repo examples in maybe not a ton, maybe 8. But that feels like a lot because some of them are complicated. They use reusable template patterns, and these are all things that I consider production worthy because I have clients that implement them and with very little changes. So go check out my GitHub examples in GitHub. But in this repo, what we're doing examples of are Renovate, Dependabot, which are the two, in my worldview, the two best or only maybe open source dependency managers that they don't necessarily use AI. They just use a daily cron workflow to go check all of your dependencies across all the different ecosystems of tooling. They also happen to support Docker files and Kubernetes and Helm charts and compose files. So they support understanding the difference between image tags and digests. So what we did in this repo was we threw in there's a bunch of documentation you can read through later. We talk about the tool list that we use, all open source. And we've already broken down this image tag versus digest thing. But I try to even break down what tools you need in order to make sure you have full coverage. And to Eric and I, full coverage looks like the minute that you're following a tag, whether it's the major, minor, or patch version, you're going to have that tag and you're going to have a digest in every place you specify an image across every file type. If you specify an image, you're listing the tag. We shouldn't say pinning the tag, but you're listing the tag and pinning to the digest. And you have automation that detects every single digest update probably on a daily basis. You probably want these running daily. I used to run weekly, but I don't think that's the best. I think it's just easy. It's a very quick check. Like these CIs run for a couple of minutes, and they check, and then they're done. If they don't have a change, then they're not going to bug you. They're not going to create a PR. But in this diagram I made, it's a little hard to follow. I wish I had better drawing skills. But the green things are the different GitHub action workflows. And this one in the middle is your very normal GitHub action workflow that all our apps typically have. Is if someone puts in a human PR or an AI agent puts in a PR and there's an app change, we do testing and Docker builds and linting and all the things we normally do. But what I'm suggesting is potentially up to three new workflows. The first one is this is essentially tell your Renovate or tell your Dependabot to check for Docker type updates. And if you go into our repo, that's not very complicated. Most of you are probably actually doing this. But if you like Dependabot, which is GitHub specific, it technically it can technically run elsewhere, but most people just run it on GitHub. If you go into the Dependabot YAML, which you can add to your repo, it's 10 lines, 9 lines, not even 8 lines without a comment. And what I'm telling it is go check for any Dockerfile or anything Docker related, meaning Kubernetes, Customize, Helm, Docker Compose files, code.yaml files, anything that has basically YAML or Docker files. And daily check for new tags or digests of my pinned images that I've chosen from somewhere else. I wanted to make a new PR, and I actually wanted to change. This is actually just changing the title to make sure that it's very clear. This is Docker. And then I'm saying, don't do this for major versions. This is just an example of maybe how you can control the change rate. If you don't want the robots to give you PRs for a major version of Postgres or a major version of Node or of Java, then you can put something like this in as an example to basically say, hey, I'm cool with you giving me PRs to approve for minor and patch versions or just simply digest changes. But if it's an actual major new version, I'm going to probably know about that as a human. That's just a choice for your team to make. There's no right or wrong reason there. And then, and if you do this, boom, you start getting daily PRs. Those daily PRs look like this. This is one where these are very simple examples. I didn't need them to be complicated. But this is a PR created. This is actually created by Renovate. Let's look at Dependabot real quick. Right here. So this is a PR from Dependabot that is changing a whole bunch of Docker files in one go. This is actually a choice I made in Dependabot. I said, please give me a PR for all of the Docker at the same time. You may not want to do that, and you probably don't even have more than one Docker file unless you're mono repo. So this is kind of a mono repo example of a whole bunch of different Docker files. And you'll notice it's looking for the most recent major or minor, but it's not yet pinning digests unless I have a digest already. And then it changes the digest for that version. So it's smart enough to understand the difference between tag and digest. And it's not, this is kind of like a gentle mode, I don't know, of implementation. So Eric and I have done lots of implementations, and sometimes you just don't want to upset the apple cart. So you don't want to pull in this giant new process that suddenly just handles every repo suddenly and throws in a bunch of SHA hashes. So we're just simply saying, hey, give me some updates. This is probably on any mono repo. You wouldn't really do a single PR like this, because this is like this is sort of like what I would call the shock and awe campaign of implementation. But you can see how this Digestibot this Dependabot, I get those confused sometimes. Dependabot recommends these changes, and it can handle digests, which means if you just did it this way, you'd always have the freshest digest. And every day that it checks, if there's a new, and this is exactly the silent rebuilds we're talking about, that there's a new digest build for the node 24, and it's going to recommend the latest one. Now, I don't know how many were built in between. I don't really care. But at least it's that smart. Renovate can do the same thing. It's very similar. It's got a lot more customization, I think. So you can really sort of tweak a lot of things. Although these tools are getting very similar, like Dependabot and Renovate are so similar that I was having a hard time finding differences. But one of the differences out of the gate with Renovate, and you can the way you see I've tagged these as Renovate. That's actually something that Renovate you can configure. So I know that these are coming from Renovate, and it's doing individual PRs per type. So in this case, it's finding two here that it's changing the SHA hash and the tag version. So it's enforcing SHA hashing on existing images that don't have SHA hashes. So this gets the Bret seal of approval. Like, this is good, because not all my developers know about this. I can be, as the DevOps person, I can sort of gently hand them this PR and say, yeah, we're just going to be very specific and make sure that we're guaranteeing the exact build is across test and staging and production. And so I can do it this way, even though not all my images have them. You can also see another type of update where it went from SHA hash to SHA hash in the same version. And you'll notice the title, right? It's not telling me it's changing the version. It doesn't know there is no version change in the tag. It just knows there's a new digest. So it's changing the title of the PR, whereas for the version change, it knows it's updating the node versions on those Docker files. It even tells you in the markdown. So these tools are getting pretty sophisticated and will tell you about not just tag versions, but digest versions. So now we've helped you understand that you should basically be doing this digesting across all your files. You can automate it with those two tools. And special note for Dependabot, I'm going to have to fix this 1,000 times with AI in post. Digestibot is a tool from, I have a comparison here. Digestibot is a tool from Chainguard, and it's kind of got the Unix philosophy of it's a single tool that does one thing really well. And what its goal is to simply find an image digest somewhere and then update it to the latest digest. So it doesn't do all the other package managers. It's container image specific. And in some, we've got some notes in here that in testing, there are edge cases. So we give you some guidance on when you might need to use one tool or another, depending on what you're trying to achieve. The goal really is, if you're using Renovate, you might be able to get by doing all of this, including your app updates and everything, all with one tool. Dependabot works in most cases. It doesn't yet work with Chainguard images due to registry differences. The Digestibot from Chainguard, since it's a very small, simple utility, a single binary probably, for instance, it can't help you update GitHub Actions. And we, as a special mention, is you should also, if you're going to be using GitHub Actions, you should also be pinning your GitHub Actions, because most GitHub Actions use images. So we should pin those too. And we give you examples of that. If you jump over to the pull request, you can see these are changing the GitHub action file for the workflow to have the latest version of Renovate Bot, which is the GitHub action, or the action for Renovate under the Renovate Bot account. It's changing the version from 17 to 18 of that GitHub action, which helps guarantee that my CI is also safe, because I can't trust my images if I can't trust my CI. So we've got to protect CI by getting the latest versions. And if you're someone who knows about something like Singularity, you want to pin to these so that you don't accidentally get upstream changes, which might not be legitimate. Like, there have been cases this year, multiple times, where rogue people have been able to get into GitHub actions through PRs and issues and like bugs in the design of people's GitHub repos. It's not a GitHub insecurity, or it's not a GitHub fault. It's just that people are misusing these tools. So they kind of accidentally let in bad code, which someone then presents as a new GitHub action, because the bad guys have figured out GitHub Actions is a good attack vector. It's your CI. It's like the most precious thing ever. It's got all your secrets. It's got a lot of things in it.
Yep.
So you got to protect it. And this helps us control every single action down to the bit to make sure that that action is approved. And we can do all that with Renovate. We can actually, we can't do it with Renovate. We have to do it with Dependabot. We have to do it with GitHub Dependabot, because it's the only one that supports this as of today. So this is all in the README. You can read it all later. It's all detailed in there. So that's the GitHub Actions. And if you go back to, I'm going to wrap this up, and we're going to talk about a Dockerfile example real quick for a real world deployment. But that essentially gets you this workflow up here and this workflow down here. These are daily checks, checking for these digests, applying them to your GitHub Actions, applying them to all your images. A future goal for me, something I was working on over the last day, is I think this part is necessary, and I'm giving you examples of how this works. I will simply say, we're not going to demo it fully, but this is going to do gripe scans of all of those image digest changes, and it's going to do a before-after CVE comparison of, if you're changing the digest, let's at least do a CVE scan so we know if we're getting better or worse. And that's a pretty easy thing to do. It's all in the the diff of the Git changes. So I've actually got a PR I'm working on that I didn't feel comfortable merging today, but I've got essentially this scanner that's going to, it's not a big workflow, but it's a bunch of shell script that's going to pull out gripe scans and help you understand in the moment of the PR what's different between your current build and the new PR build. And there's tools you can do to do this. Docker Scout actually does this. I think Sneak might do this. There are tools out there that can already solve this problem for you, but it's not, it's 100 lines of shell script. It's not, at least for the basic part. So that's something I think that's a little essential, because it would be nice if we knew what was going on in these in these digest changes. So at least we can know, we maybe won't know like the file list of changes, which we could do, but at least I care more about the security of the CVE part. So knowing all this, stepping back for a second, I'm going to check chat for questions. We took this mindset and we said, okay, well, the first thing we got to do with a real world example is we got to convert the Dockerfile to a better base image. So let's, Eric, you have a show and tell for me. I'm going to share your screen.
Yeah, and before I get into that, I just want to underscore the scanning part of that. No matter who you're getting your images from, whether it be somebody that says there's zero CVE or hardened CVEs or whatever, you should still be scanning. Don't just assume, oh, I've paid a vendor or I'm using a project that gives me low CVE counts. No, you still need to scan both the base image itself to make sure you're getting what you think you're getting. Make sure it's up to date and you haven't got an old version that CVEs have started to be found in. And then whatever you're adding to the image, that's on you, and you got to make sure that you're not adding CVEs to it. And that's kind of what goes along with what Bret was saying. Automate that scanning. Make sure you're still scanning. Runtime scanners are great. Pick your scanner. I don't care which one you use. We use Gripe at Chainguard because one of the maintainers works with us, and it's a great scanner. But I used to work at Sneak. I liked Sneak as well. So um, what we're going to talk about now is we were looking around for a good example, and we picked Mastodon because Mastodon is big. And it's a complex Docker file, but it makes a lot of sense if you read it and grok it. So um, let's show them. Let's show them my screen, and let's get into the Docker file a little bit, and I'll walk through this. And there was a couple questions in chat about when you get into a lot of hardened images are distroless type images. Chainguard does distroless type images. Those images don't have shells, package managers, all sorts of tools in them, which is good because you don't want to give an attacker a tool to use against you. But how then do you modify that image if you don't have APT or APK or you don't have a shell? How do you deal with it? How do you use it? How do you troubleshoot it? All those kinds of questions come up. So we'll try to touch on all that.
Yeah, Paracha asked that similar question around, is there a way to install additional packages that you need on top of the base images, or is that just against the idea of secure image use? No, absolutely. I mean, Eric and I we've been converting Docker files for over a decade. It is a very common thing to need various packages, and on your language and framework largely depends on what package managers you're using, and they all can work. It's maybe just a little bit an extra step or two from where you were before, where everything was apt or yum. But yeah, you can totally do this. I wouldn't say any of these hardened image platforms turn away apps because they won't work in hardened images. Like, there is a path forward. It's just a matter of learning the tooling that you need to do that. There's one other question, Eric. We always have GitLab fans in here. I don't have my GitLab hat on. It's somewhere in the room. We had to pick an example, and GitHub Actions is the most popular CI on the planet. But GitLab is more important that you're using these workflows are all open source. They're all YAML. There's probably, I know there's a converter that will take you from GitLab to GitHub Actions. I'm assuming there's the inverse of that there's a tool that will convert. So you certainly can do this. It maybe would only take you a little bit of time to look at our steps, understand what each step is doing. That gripe scan thing I was talking about, it's just a shell script that I'm using AI to create. So you can reproduce these steps of that diagram. I mean, that's the reason I wanted to show the diagram was regardless of what CI, whether you're using Jenkins or anything, your mindset just needs to change maybe a little bit to, we're not just doing Docker image updates for app changes. We're also automating all the PRs for any digest changes. And that's, I think, like the new gold standard for keeping yourself as secure as possible. We're not going to always all be 0 CVEs, especially when things drift over time. Like, not every image in the world is getting updated every day. So you will have CVE counts going up and down in production. It's almost like a sine graph of, like, they go up and then you find fixes and you deploy updates, and we're just trying to automate as much of that as possible. We're not saying that you can, by automation, you can guarantee anything's perfect. But I feel like at the end of the day, I'm done checking for new things. Like, I just want PR approval for all these things happening outside of my repo. So anyway, that's like a couple hundred lines of YAML, I think, was what we're talking about. I'm going to shift over to Eric's screen. Can you zoom in for us, since we might have about a quarter of our audience is on mobile. So hit that button a couple big times.
So I'm not going to live in this Dockerfile that much because it's a eye chart, but this is the original Mastodon Dockerfile as of a couple weeks ago, honestly. And I've actually cleaned it up a little bit to make it easier to scroll through, but it had 400 lines, 402, I think was the count. I've got it, removing comments, I've got it down to 367 just so a diff looks nicer. But let me preface, I am not a Mastodon maintainer. I know nothing about the code, and I am a very novice Ruby developer, and I suck at Node.js too. So this was a great one for me to choose to try to migrate, right? But before we get too far into it, you'll see that this has it's a multi-stage build, which, lots of from lines. And so there's, I think, 6 or 8 stages in this build. So in order to better grok what is going on, I made some very blocky charts here. And let me start this off. So what we start with is 2 stages in this Docker file. We've got a node one, which actually does nothing. All it's doing is says, set up which node I want, which they're using args and things for, and then call it node as a stage. And then same for Ruby. I want Ruby with 347 Slim Trixie, and we're going to call that Ruby. Now they do also add some environmental variables. They create a Mastodon user and some basic APT installs in that stage. So anytime you see Ruby used, that's where it's starting from. The next thing they do is they have a stage called build. And Ruby, they start from the Ruby starting point that has those invars and everything else in it, and they add build dependencies, whatever they're going to need to do builds. The next set of stages are building libvips and ffmpeg from source. They're actually pulling down the source and compiling those in those stages. And there's a bundler stage that copies the gem file in it and runs bundler, which gets all the gem stuff. Again, Ruby, whatever. The cool thing about this pattern is that BuildKit is very smart about parallelizing things. And once it has built the build stage, all three of these stages most likely can run in parallel now. So that's pretty cool. Speeds things up. And let me get this out of the way. Then we've got a stage called precompiler that depends on build again. So it's going to copy in the app from that bundler stage. Whatever bundle did, it's going to copy that in. It's going to copy in the binaries from that node image that is sitting out there so that we have node available to us in here. It's going to run CorePak and Yarn. It's going to copy in the binaries from libvips and ffmpeg, and then it's going to finally do the Rails precompile. So all of those things are coming in so that they can do the JavaScript side and the Rails side precompile stuff. Okay, so we have a stage precompiler. Then finally, the final stage in their Dockerfile called Mastodon is starting back from Ruby again, back at the red block, right? So again, we're starting from a point of where we just have Ruby plus environmental variables and a user and some basics. We're then going to install our runtime dependencies. So the build dependencies were in the build chain, if you will, hierarchy. We don't want any of that in our final image. So this is actually a pretty good design. Install the runtime dependencies, copy the app in, copy assets and binaries from all of these other stages that we built them in, run a bootsnap precompile, where the heck that is, and then set up some ownership and directories and volumes, whatever, and then set up our entry points and users. So that's the gist of their Dockerfile. When I went to convert this to use a Chainguard base, the goal being I want to reduce CVEs. I can show you, I just ran a gripe scan while Bret was talking. The Mastodon 444 official image, which was the one that I was working, and when I was doing this work, this was active. If you scan it today, you're going to see it has 150, I mean, scroll up, make that font bigger.
Yeah, I was going to say zoom in a little bit.
It has 155 vulnerable matches, 0 criticals, but 17 high, 26 medium, 17 low, blah, blah, blah. And gripe is showing you all of the vulnerabilities that make that up.
It's a lot. It's more than one person can probably comprehend.
Right. It is what it is, but that is there. Yeah. The chain, just to bury the lead, the Chainguard version, which I just built, throw that font up a bit, ended up with 1 high, 4 medium, and no others. And the no high is actually in a gem. It's not in it's in something that's being brought in by Rails. Or Rake. And
I should point out, by the way, I should point out, by the way, kudos to the Mastodon team, because I looked at the Mastodon image maybe a year and a half ago. It took over almost 20 minutes to build. Now they've got the build under 5 minutes on my Mac. So yeah, this image has gotten a lot better, a lot more sophisticated. It's actually why we chose it was the level of sophistication. Like if we could do this kind of migration to Wolfie distro, like if we can do that to a really complicated solution that's got hundreds of lines of Dockerfile, then probably anyone's app will work, right? We wanted a challenge, and we spent. I thought it would be. Yeah. It was a challenge. It was not something we just did in an hour, or that we could like give to AI to do for us. It required some sleuthing and deeper understanding of package managers and how files are moving around in Docker, which is why I think that for Docker files of any reasonable complexity, you still need you probably still need to understand the context of everything and how everything is coming in,
Yep.
which is why you have to learn Docker so well. I think sometimes people don't appreciate how complicated this stuff can be.
Yep. So when we go to look at the diff and we look at the ChainGuard version of this, I'm starting, I don't need a node image, and you'll see why in a minute, but I'm starting with two. I've got a Ruby production or prod stage, which is the ChainGuard Ruby latest, which is the distroless type. It has no shell, package manager, any other tooling. It just has Ruby, doesn't have Rails in it, any of that. And I do the same add of invars to that and put it aside. And then I've got the Ruby dev variant. In ChainGuard speak, that's the builder version, right? It's the one that has Rails. It has APK tools. It has all the things you need normally to do iterative development or building of apps and things. And we're going to call that Ruby dev. We're going to have the same environmental variables to it just because they're needed for the app to do things. I think, again, I'm not a Mastodon developer. And I'm going to
right. We're actually this is proving the point that we're migrating an app that we did not build, right? Like we don't know this app. The only thing we can look at is the repo to understand how it's made. Yeah.
So and then we're doing similar user creation, apt-get install. It should say APK add. Sorry, copy paste problem. And then I have this. I wanted to follow the same pattern. So I have a build stage, which depends on Ruby dev, and adds the build dependencies with APK now instead of APT. Then all I have after that is a bundler stage to do that gem file run bundler thing. I don't need to build my own FFmpeg and libvips because ChainGuard's already doing that for me. We have APKs for that, and they're doing it in a hardened way that I don't need to worry about. So I'm not going to do those on my own. So then when I get to the pre-compiler, we're just coming from build again. We're going to copy in the app from bundler. We're going to add in the APKs for Node. Instead of copying binaries from another image, I'm going to use the Node APK from Wolfie, from ChainGuard, Rails, libvip, those things I need. I'm going to do the same running of Corpac and Yarn and whatever that they did. Again, copy paste. See, I did these right before here. Ignore the copy libvips. That's not happening. That's copied from the old one. But I am running Rails to precompile. I got to clean these slides up before we give them out. Now, before I can make the final stage, which is going to be based on that Ruby prod, I've got things I need to do that I can't do in a distroless image. I need to install runtime dependencies and set up, things that I need APK or shell or whatever to do. So I've got an intermediate step I'm calling Mastodon prep. It's based on Ruby dev. And we're going to get into this in a little more detail here in a second. I could just, literally binary copy files down from things and try to keep track of all that and know what the transitive dependencies and linked libraries are for things. But that's a mess for anything but the most simple binaries. So we'll look at a way to do this in a second. But I'm going to set up a prep, and I'm going to file system prep area, hold that thought. We're going to add our runtime dependencies to it using APK, including FFmpeg and libvips and everything I need, set up any directories and ownership, and then we're going to do the same things that it did before, get everything done that I needed a shell and a package manager for. And then finally, in the distroless final stage, based on Ruby prod, I'm going to copy that file system, the changes I made there, on top of my prod image and bring everything I just did down. Again, hold that thought. I'll show you how that gets done. And then finally, I'm going to copy in all the other things the app needs to run, set up my user, my entry point, and now this runs without a shell, without a package manager, and it's distroless. So I said to hold that thought. So when we look at distroless type images, you often have this base, Ruby, whatever in this case, and then you've got all these apps you want to add to it, and that's what these colored blocks are meant to represent. I've got all these things that are going to modify the file system of this base package, but how do I get them in if I can't APK add them? And I don't want to do, like I said, I don't want to copy JQ and JQ's SO and whatever other SOs it needs, and then worry about SO numbers changing over time. So what you can do is have the dev version. That's what the build prep stage I showed you before, which is based on
by the way, I didn't know how this worked. Like you taught me how this is a pretty slick way.
And this is just a pattern. I'm not saying this is the only way to do this. This is one that we've seen a lot of success doing. So you've got your stage that I'm calling build prep stage. and it's based on the full image. In that case, it would in the Mastodon case, it's the Ruby dev, Ruby full, not the distroless. And I'm going to create a directory, just foo, whatever you want to call it. And I'm going to copy the file system, the root file system of that distroless base into a directory here, so a subdirectory. Then I've got all these packages I care about over here in the repo. I'm going to install them into that file system using a functionality of the package manager, which is a lot like the chroot. If you're familiar with Linux admins, you can chroot into, say chroot this directory and then run things in it. And that says, okay, the root file system for the process being chrooted is foo. So you have to have it in, all the things you need have to be in there. Well, APK can operate in a way that says, hey, even though I'm running from the context of the build stage, the prep stage, everything I do is in the context of whatever you tell me. You say -- root, foo. And now it's going to use the APK repositories files, the world file, all the things that it does, and all the mutations it's doing are going to happen in that directory. So this is the file system of the distroless base with the changes made by APK dev. Then, in my final stage, I literally tell Docker, in the Dockerfile, copy the foo, what's in the foo directory of my build stage, on top of myself, on top of the root of this image. And Docker, at the end of that operation, that copy operation, knows that the layer it creates will be the delta. So the things I just changed are what get copied into this layer, which are that app, including the manifest data from the APK adds. So you're keeping your scanners happy. So when you scan this image when you're done, scanners are pretty smart, and they can do fingerprinting and find things even though you didn't, if you copied them, manually. But in this case, I've got the APK manifests that the scanners want to see and the SBOM creators want to see, so it knows where these binaries came from. And so then we have our final image. To see what that looks like in practice, let's go back to my IDE. And I'm going to go to a diff between the original and mine. And there's a lot of changes, because just bulk changes, whatever. But you can see here's my, I'm using CGR div. I just make it clear. I just put the hard code. You could still use the variable names for these things. But there's my, gosh, that font is so big I can't see everything. There's my Ruby dev stage. I'm not going to walk you through it because this would be boring. You can look at this after the fact. We'll give you the repo. Here's where I'm doing
I posted our fork of Mastodon that Eric has worked so hard on this week and last week actually.
The hard part here is mapping apt packages to APK packages. We actually have some tooling for Chainguard to do that called Dockerfile Converter. It's a DFC. We'll put the link in there. But it does a lot of that work for you and figures out from what we've seen over the years of what's the matches. And I'm just I'm going to scroll down because this is the minutia of doing this is what you need to copy in, what you don't. I don't need to build from source those two things anymore, so that got removed. And we get down to here's that prep section. In fact, I'm just going to look at it. The diff is going to make this too ugly, so let me just pull it up here in the main file and scrolling. I should just search, but I'm already committed to scrolling. Here we go. So here's Mastodon prep. I'm going to take this out of order because it makes more sense if I do that. But the first thing I'm going to do is I'm going to copy Ruby prod's file system at its root into something I'm calling base chroot. That's what I wanted to name it. Ignore this first APK add. I'll come back to it. Here I am going APK add, no cache, because I don't want to deal with having to do updates and keeping track of that. So I'm just saying, just do this as a single, operation. And I'm saying use the root base chroot and add these packages. So that tells APK add, okay, step into base chroot and operate as if that is my root file system. So it adds all these things. I'm doing some other things in here to prep the file system, doing some chrooting in. This is actually a check they were doing in there. I kind of like where they're actually running the different tools to make sure that they at least are sane. So the build will break if all of a sudden
the ones that they
FFmpeg
custom built.
Work.
Yeah,
exactly.
The ones they custom built. Yeah,
I left it in there. Might not need it now, but I decided why not. Okay, so then you saw that I put a shell in there. APK add. Before I did the main one, I said, okay, let's add bash Bash binsh is just bash with a symlink from binsh. I'm adding that briefly, and I'm taking it back out when I'm done. Why am I doing that? Because APKs, when you install them, have hooks and scripts that can run as part of like a post-install thing or whatever. And I don't want to learn and find out if any of these need that and then break if they don't have it, because there's no shell in this base to rooted area, right? So what I'm doing is I'm saying, hey, ignoring any hooks or scripts that bash binsh has, go ahead and in the base to root, add a bash shell. Do these installs, let them use that bash shell to do the installs if they need it, whatever. And then APK delete it back out. Get that shell back out of there. I don't want it when I'm done. So all of that gets done. I'm doing some other cleanup just because I know there's some things in there I didn't need just from what I was reading from, diffing what my image was. Then when I get down to my final stage.
By the way, I should mention that the eagle-eyed Dockerfile guru would look at that and feel like, oh, wait, you can't remove it in a further step because then it's still in the image layers or whatever. But you're solving that by a copy from later on, yep. I assume? Yeah, okay.
So here in the final stage, the Mastodon stage, which we start from the distroless Ruby prod, the first thing I do is I copy from that prep stage that base to root directory, and I overwrite my entire root file system with it. Now, this only works if this from is what you copied at the top. It has to be exactly the same base. Otherwise, you're gonna bring in a gig or whatever, hundreds of megabytes of data. You don't want to
the entire thing. Yeah, you're gonna bring in the
wrong. So
you
want to make sure that the prepped file system is the file system that you're starting from in this case. So again, when this is done, only the delta should get saved in that layer. And then finally, I'm doing all the other things. I'm copying in. So I can't do group adds because I don't have those tools. So I did that already in Ruby Dev. So I'm just going to copy my time zone setting, my password group shadow files, all the things I need to find that. I'm copying that down here too. Doing these same things they were doing before, copying whatever, set that user, set the workdir, set the entry point, and it works. You have to take my word. I'm not going to demo it right now, but there you go. So that was a very rapid fire walkthrough of something that took me a couple days to do. This is not trivial work sometimes, especially on a big app, monolithic app like this. But if you've got smaller apps, honestly, there's often a one-to-one of the APT to the APK, and you just say, you get into a shell or something, say APK search, and find the thing you need. And just, okay, well, that's the mapping from this to that. Or, like I said, if you're using Chainguard, you can use the Dockerfile converter tool we have to help you weed those out. I've been talking a lot, Bret. Anything in the questions or anything you want to throw in here?
No questions yet. I was gonna bring us back to, anytime. I think there's two parts of this. Like this is a really long talk, and I think it's necessary to because this is a complex topic. But there is the act of getting your images to a, whether it's Alpine or Wolfie or something that's a lower CVE default, because you can't really, it's hard to remove CVEs from a base layer, a base image that you're pulling upstream. It's hard, right? We've seen apt update, apt upgrade, at the top of Docker files before to try to lower that. And that does work. It's a non-deterministic update. So it's not great, but it does work if you're using, Python Slim or something like that, where you've got potentially dozens of critical and high vulnerabilities in there. So ideally you get to Alpine, and ideally you even move off of that to Wolfie or another officially hardened image solution, because there's now multiple options out there. And I think we're going to see the trend is companies just taking the easy button and purchasing these paid base images, because just like paid versions of Red Hat and paid versions of Ubuntu, like people in enterprise do pay for that safe underlying starting point. And this stuff is hard. So not a lot of people will go through that level like you did with Mastodon for all their apps to get the nuance of reducing the dev dependencies that are in production, which isn't ideal, but it's hard. It's hard. I mean, that's hundreds of lines of Dockerfile and in one line of that Dockerfile isn't correct, you end up with a bunch of this in production accidentally because you forgot to remove something or copy something over. I wanted to go back to this image real quick, because the point is that you could do the ninja level effort that Eric did, and you could get it down to 0 CVEs. use Chainguard images. They're guaranteed 0 CVE.
Or close to it.
Or close to it. Like they're guaranteed to fix the vulnerabilities at least very quickly. I think it's days. Like your all's.
Yeah, I mean, it depends on the upstream as well.
Public
If the upstream is not fixing something, we're not magic. But most CVEs are not in the main package. It's in all the things that are in the distro. That's why distroless is so powerful.
Right. And most apps, like I think that a lot of teams today have learned to use Dependabot or Renovate to update their app dependencies for security. I mean, GitHub kind of enforces Dependabot on you for security notifications. So a lot of teams have just automated that stance, but they don't control what's in the base image that they're using from upstream, Docker Hub, or wherever. So whether they're using Google distroless or AWS open image repository, like they're using something. I know that like in Cloud Native, we use some Quay images, but the day one, or we would call that, to me as an operator, this is day one, building the image, getting it to low or 0 CVE, and then deploying it. But this talk turned into being more about day two. And that's what this diagram is meant to represent. Those orange workflows that I'm adding, those orange steps that I'm adding to anyone's GitHub Actions, because presumably they're all either it's GitLab or Jenkins or GitHub Actions or one of the other dozen options out there. Presumably you're building your apps automatically through PRs to any time a human or an AI agent updates code. Most of us, we started with images, and whether it's in Kubernetes or Helm or whatever, we started manually waiting on humans to update those. Some teams have moved to automatic tag updating, maybe not digest yet, but we want to push you and nudge you that little bit farther to all of those images need to be digest. The tools exist to do it, and they'll even add the digest for you, so you never need to go get the original digest. And then to have these daily checks for new digests in GitHub Action workflows, new digest in your container image upstreams that you're pulling. And if you can do that daily, you'll start to notice you're getting a lot more PRs for these, minor little changes of upstream images that maybe don't change anything. And then my stretch goal, my Kickstarter stretch goal for later. So follow the repo. I'm going to do a little ad plug here in a minute if you sign up for the emails, we have emails detailing a lot of this stuff, and we'll keep you updated on the progress of this repo. You have to get that through my website. You can actually, let me do clipboard history. I'm going to put this in chat. It's actually at the top of chat. This is signing up simply on my website. You'll get a couple of emails from Chainguard and myself about this event and about Chainguard. But the point of that email was to not just notify you about this event, was to keep you updated on any changes that we do to this. And I personally want this gripe scan of my PRs. Like I actually want in my own repos and all my own examples for my own consulting. And by the way, did you know I have a GitHub Actions course? Like I'm building GitHub Action courses. I want this content in there because I want this. I want automated daily checks. I want diffs. I want distribution images upstream to automatically digest into all my GitHub repos. And then I also want scans that tell me, hey, your old image that you were deploying has this many CVEs, the one you're on today in production, and then this change in this PR is going to result in a difference. And there's multiple ways to do it. Like I said, Docker Scout does it. I think Sneak does it. Other security companies will do those diffs. They'll even do things like check production clusters. And you can find that there's something called Trivy control plane. I think it's a controller for Kubernetes. Trivy has one. I think Gripe might even have a tool for this as well, where they can scan your production to see what images you're using there, and then scan those CVEs and compare them to your PRs. Like you can get super fancy. But I think for us, we wanted to just give you that these actions are pretty small. The last thing I'll say, actually, I got two things to say left. We are running a little short on time, but the two things I want to point you to is in the Silent Build repo, when you go and look at these workflows, Renovate has a config, Dependabot has a config. The YAML files are actually quite small. Like this is 27 lines to run Renovate against all my my images. To change all my images is that, because it pulls in the config file, and then there's what? Yeah, 20 lines of actual changes. And I tell it to separate out majors, separate out minor updates, separate out major updates, so I don't cobble them all together. Add labels to when you create the PRs. Like, it's got a lot of intelligence around how to create those PRs. Force pinning of digest so that I always have digest. So that's a very simple example. It's all in the repo. And the point is, there's not a lot of effort here. It's not a huge lift. This isn't a 6-month project for you. At least it shouldn't be. I hope it's not. To implement. And you can see that I've got this on schedule, going every day. And all it needs is a GitHub token, and it runs the Digest-a-Bot, in case you need it, is that sort of last little option in case you're not using Renovate and you're not using Depend-a-Bot, and you maybe just need to implement this one little change into your workflows. You can do it with Digest-a-Bot, which just affects those digests for images and doesn't touch anything else, doesn't care about anything else. And so that's a pretty cool option as well. The last thing that we teased, I don't know do you have any comments on that, Eric? Sorry, I should take a breath.
Mm-mm. I replied to somebody, and there's other ways to customize images if you're paid tier on Chainguard. I didn't want to get into paid tier stuff, so
yeah.
If you are one of our customers and you want to know more about custom assembly, reach out.
Anyone, by the way, if you want to throw in some last minute questions, we're going to wrap up in a minute. But a bonus round besides the Mastodon, I feel like the Mastodon image itself was a bonus round, and you teaching me about this Chroot scenario with APK. That's a pretty cool thing.
While you're minting it, so somebody asked if you can do that with APT. That's a great question. I don't know. Possibly. I live in the world of APK, so I don't. Possibly. But again, the APK Chroot thing is more of a nuance of the APK bit. The point was set up the file system how you need it to, using whatever machinations you want in that prep stage, and then copy it over. That was kind of the gist of what I was trying to get at there. Is APK has this tooling to do that.
Yeah.
Whether APT does or not, I'm not sure. I guess you could probably install APT Chroot, actually Chroot in, run it, and then remove it. I don't know if it doesn't have that function.
It would be a cool feature request to APT.
It may
PR's welcome. The ones there was something I was going to say there. And I lost it. It escaped my brain. It'll come back.
I have a couple distrolist comments to make.
By the way, hi Zolt, from our by the way, if you didn't know, we discuss this stuff. If you're new to this channel or haven't watched my live streams before every week, we have a huge DevOps Discord server. People are in there chatting every day. I can't keep up with it all, but I manage this thing along with a lot of volunteers, and Zolt's one of them that volunteers to keep the spammers out, which is more prevalent than ever, sadly. I guess because of our popularity, maybe I should take that as a compliment. But we're constantly defending the quality of the community there. And please come join us if you want to talk about this more. Hopefully, we'll be chatting about this later in there. You had some comments. Sorry, throw those.
Oh, just other distrolist things that come up beyond Dockerfile. So Dockerfile is the first thing you hit, but then using a distrolist type image, whether it's Google distrolist or Chainguards or whatever, there's a couple things that come up that people question is troubleshooting. How do I debug? I can't exec into that thing. How do I do it? There are patterns for doing that. We have a couple of courses. They're behind a reg wall, but they're not paid or anything. There's the link to the top level. We have an onboarding Chainguard images. These are two courses that I've done. If you go down and scroll down in that list that you get from there, there's a Containers 102 that actually talks about the pattern I just showed you. So you can look at that. And then there's a debugging Chainguard containers. That one gets into, well, what can I do if I can't exec in anymore? And the first thing is, well, make your app emit more metrics, because that's usually the problem. But how to use, Docker debug if you've got it, or Kubernetes debug, or starting up a container in the same PID namespace. All of those kinds of topics get discussed in that.
All right. Could you give me that link in Zoom, and then I can post that in YouTube?
I will. I just posted it in YouTube, unless it didn't go out.
Oh, you did? I didn't see it. Sorry.
I may not have rights though. So yeah.
No, you should. I gave you rights. Please hold.
I think it went out.
Hold. It was just a while ago. I don't see it.
Who knows? It's YouTube.
All I see is you commenting on paid tier.
It maybe I'm not super moderator anymore. I've been
I
demoted.
checked. You are. We'll worry about that later. All right, I'm
Good
putting this
stuff.
in chat. This is a link for that guide, those courses. That's very cool. The last thing I wanted to leave you with was a quick tip. So there was a hack. We've had a lot of hacks lately around NPM and GitHub Actions. And GitHub Actions this year GitHub Actions has gotten so popular. It is the most popular CI and automation platform on the internet. And I'm trying to pull up this repo. And Singularity was a particular attack on, it doesn't matter, it was on an NX package, but the way that they got in, and we're finding multiple examples this year, especially if you start looking at AI MCP tooling, but there's a way that if you're not careful in open source repos, that people can make PRs with their custom nefarious code that's not what you want, and they can apply that through PRs or issues. And if you don't have proper GitHub Actions lockdowns, then you accidentally might run their code automatically without manually approving it or verifying it first. Which means anyone can run anything in your GitHub Actions or in the security envelope of your repo, which is very bad, not ideal. And that's what happened with the Singularity attack. I just wanted to give you like 3-4 settings. If you just change these settings or go and ensure these settings exist and they're set the right way, you can prevent this style of attack, even if you accidentally write, like one of the things they did was the repo had a GitHub action that parsed titles and descriptions of issues to determine something about them, like maybe to label them. It's a very common thing, but that allows for script injection, just kind of like a SQL injection. They just put the script in certain tags and got it in a certain way, and then accidentally were able to run code through a GitHub action. So these kind of things you can limit the blast radius with just a few simple steps, and I wanted to show you real quick. I actually did a talk on this at a local Azure meetup last week as a practice, but if you're just in your repo, you go into settings, you go into actions, click on general, and you have an increasing number of settings here, but if this was a private repo, I'd actually have one more setting about whether or not the rest of my org could access GitHub Actions in this repo, but we don't have that one here. This setting at the very bottom is actually, to me, one of the most important settings of every repo that's public. It actually matters still if you're private, because it's possible in a private setting for people in your team that maybe don't have write access to the repo, they just have read. If this setting isn't carefully handled, they might be able to write something into the repo through GitHub Actions. So they can fork, PR, get something slid in. And it turns out that for years, and actually starting in like 2023, I've been advocating for this change in every repo. The nice thing is by default, when you create a new repo today, it is set to read only for GitHub Actions, which means every time a GitHub action workflow runs, that action by default does not have the ability to write commits or make any changes to the repo through that action. The default until just a few years ago was this one. Read and write by default for everything in workflows, which is great for convenience and for day one. Like if you're just trying to get things working, this is a good setting. It was I think it was a very bad security posture decision. And it has bitten GitHub more than once. And so they learned and made the default this. However, they did not change it retroactively because it would break the internet. So now we've got probably millions of repos, I'm just guessing, but at least hundreds of thousands, if not millions of repos with GitHub Actions that still have this set, including the repo that ran in X. So they learned about the setting the hard way. I recommend that you set this setting, and if you need to have your automations create PRs, which we just showed you today, like you've got actions that need to create pull requests from one branch to another in your repo, you've got to have this checked. So that's probably something you're going to have to. The next setting, and this is really only if you're public, but I still think there are scenarios in private organizations where you've maybe given a lot of people read access, product managers, people that don't code but need access to see GitHub Actions, see status of things, see comment on pull requests, right? There's designers, there's project managers, there's lots of people. This applies to them in a private repo, which is, I would set, if you're security minded, always require approval for any pull request workflow to run every single time unless they're a contributor on the repo, which means they're in a group. They're in a security group. You can actually, in GitHub Actions, you go up to collaborators and you add someone there. That's like standard group permissions for repos. But for people that don't have those, and you've maybe given your organization, a part of your organization, you've just given them read access to something. You want to make sure that anyone, I think they call that internal open, what do they call it? It's internal source, internal open. There's a term that GitHub uses for, in like GitHub Enterprise, private repos that are available publicly throughout the organization. So you want to make sure this happens, because what's happening right now is this is default, and people on the internet, this has happened a couple of times in the last year, they act like good actors for a while until you trust them with their pull requests. And then you've approved one pull request from them to run in GitHub Actions. Then in 2 years, 6 months, whatever, they decide to go bad actor and they submit a bad pull request and it's auto approved. They don't have permissions in the repo. They haven't gotten that yet. They just simply forked it, submitted a PR back, but because a previous PR had been approved at one point in time, now it's going to automatically run them all. And that can bite you. So I recommend, especially if you're public, you go a little more hardcore. And then I won't talk about this one. This is just basically allowing which actions can run. That's you can do that at the org level. You can do that at the repo level. If you want to be more secure and locked down, you can even force every GitHub action to be required to have that commit SHA hash to guarantee that you can't sneak in bad copies of GitHub Actions. You might want to check that. But the last thing you want to do, and then I'll shut up. The last thing that you want to do is in every action, you want permissions. Every workflow needs permissions. I don't know how to staple it on the screen. Every workflow needs permissions. If you do this, because in the repo settings, we set it to read only. So we now have to give it right explicitly in the action. I wish there was a setting in GitHub Actions that said, everything is none by default, all the time, none, none, none. If you want read access to just even the repo contents, you have to explicitly define it. I wish they had that setting. They don't. So this is the best we can do. We can go into the repo settings and say only read if anything needs write. And as soon as I set these, by the way, effectively what ends up happening is all the other permissions, because there's like 20 of them or 15 of them, they all actually go none. When I set this manually. So it's kind of nice. I set these and this becomes explicit. It gives me write access to make commits. It gives me write access to create pull requests. And then this ID token thing is just part of the pull request, being able to get some metadata and stuff. It's not a huge deal, but it's necessary. And that you need for exactly for what the permissions of your workflow. If you hired me, day one, if I'm looking at your actions, I'm checking every one of them from these permissions. I'm checking them for digests. I'm checking them for manual permission assignment, and I'm making sure that you're using the right events, because the last thing that Singularity did was it used something called pull request target, which should never be used in a public repo, except for very, very niche situations that are very minimal, like this 0.001% need to have that. We all want to use pull request. We don't want to use pull request target. If you want to know more about this, sign up on the email list at the top of chat. I will be sending out a video and to that email list about Singularity, about more of this stuff, and breaking down how it happened, what you can do even more than this to avoid it. But that's going to come later. So, whew. All right.
All those settings, can you bulk change that in an org, or is that you have to go
it's almost like I gave you a lead. There is a project called Evergreen. It is by GitHub. Let me bring that up. So if you have an org where you need to enforce automated security policies, there are ways to, everything's an API, so there's ways to make those setting changes at the org level where you can enforce it in just like a checkbox, and then suddenly all the repos have to comply. And then there's things where you have to go repo by repo or workflow by workflow. And Evergreen is a project they created last year. that enables automatic security updates and opens an issue PR in repos to an org that have dependency files but no Dependabot file. So this is specifically about enforcing Dependabot, but so you've got a combination of org settings that you can set these actions up in. I actually have an org we can look at, but it looks like the identical setting radio boxes and checkboxes. And when you set them at the org, they're enforced. You can also enforce workflows that have to run on every repo. You can enforce those at the org level. You can automate with this evergreen action for specifically making sure that Dependabot is updating your GitHub Actions digest, for example. You can enforce that on every repo through this, that it goes through each repo and checks. And then if you're interested in broader security automation on GitHub repos, if you just go look at the Actions catalog, there are definitely some projects that in the background, they talk to the GitHub API for you, so you don't have to handwrite it. And they're not necessarily GitHub official, at least not the ones I've seen, but they will help you automate things like silly little things like a list of the consistent labeling list across every repo's issues, stuff like that. Like you can set up all these different templates and whatnot. And so those also exist. So really, if you can think of it, it's probably someone's made an action to automate it in GitHub Actions because there's like 40,000 of them. But yeah, I would first look at this as well as the org settings for enforcement of that stuff.
Sure.
Any questions in chat? I think we've caught up with everyone. I think we've said everything we want to say. But silent rebuilds, I'll put this back in there one more time into chat. That's where you're going to see some more PRs and stuff happening there if you're curious about this stuff. I personally am going to focus on automating more of the GitHub Actions and providing better documentation for them so that they're reusable for you. And then filling out that gripe part where I really want an action that just checks a before and after digest and then gives me the CVE results and difference of each. And I don't think that's going to be hard for me to finish. So I'm not sure I'm going to make it like an actual action. Like I don't want to necessarily publish it in the marketplace and like have to maintain it. But for you special people, I will, keep this thing updated and try to make it maintained.
I will put my standard disclaimer out about the Dockerfile I've done for Mastodon that you'll be able to see. I have no idea how good that is as far as functional wise. Don't run that in production, please. It passes all of their tests.
Yeah.
But I am not a maintainer, so don't trust my branch and deploy that somewhere you care about.
Yeah, we did test running it on a server, but we didn't actually use it like a Mastodon instance, and we didn't do end-to-end testing.
All of their upstream action, integration tests actually ran against the containers, and they worked.
Oh, but, actually, like not just unit tests, but actual integration tests. Okay.
Yeah, they have a bunch of them that stand up containers and create database backends and make sure they work and all that.
Nice.
But, yeah, Mastodon project is pretty impressive. I've never looked at it before. I remember your year ago blog or a video where you went through it and they have cleaned it up a lot. They probably watched.
Yeah. I did do a whole live stream once where I broke down. I went step by step every line it was like a 3-hour live stream where I went line by line in Mastodon, and it's definitely improved a lot in that year. So I won't take credit, but I'd like to hope that I helped. But I didn't submit a PR to them. I just simply complained about it on my live stream and tried to fix things.
It's big, but it's pretty good.
Yeah. All right. Last little plug. If you want to check out more of the Chainguard images, just go over to images.chainguard.dev. That they've got their open source catalog there. They've got the Wolfie project on GitHub. A lot of these things you'll see in open source repos there. Not all these images are free. You'll find some of them you need to contact Chainguard for a subscription on. But they've got 1,700 projects, which is crazy considering that there's only a couple hundred official Docker images, but you all have almost 2,000. What's that?
And to be clear, just so nobody, not all of the images themselves, not every version of them is free. You go in and you see it says contact us, that's one that needs a license. But all of the ones you would think of for like open source work, you're going to find Nginx, Java, Ruby. The latest versions of those are available for on the free tier.
Yeah. And for me, I'm building a GitHub Actions course It's actually not related to this at all. We just happened to decide that GitHub Actions was the right way to demo this. I am building out a course on GitHub Actions, including courses on AI and other. They're going to be small little courses that are going to come out. We're going to drip out the content. If you want to sign up for updates, you'll get some free videos from the course. You'll get a coupon for the course when they launch, at least when the first one launches. So yeah, do that. That's what I'm spending all my free time on when I'm not here with Eric, trying to lock down images and create GitHub Actions for the internet. So thank you all for joining. If you've not seen this stream, and if you've not been on my channel, Eric's not always around, but he's sometimes hanging around in chat. I try to live stream every Thursday or most Thursdays, and we also have podcasts. We have a newsletter. There's things going on here, so check out the channel, subscribe for updates, all that stuff, like and subscribe. Yay, I said it. I said it at least once. I normally don't ever say that because I feel like, even though I'm a YouTuber, I feel cheesy saying like and subscribe. But people forget. So do that. And then, if you want more information, sign up for the email at the top of chat, and you'll get a bunch of emails. Not a bunch. You'll get an email or two about updates that we're putting in to this repo as I make some changes. And we will also be editing this video down. So
I'll throw your new podcast to plug, the Agentic DevOps podcast. I am so far behind on it. I'm trying to catch up. But the interviews you do on that, the people you get for those interviews are amazing. If you're not following that podcast and you are interested in any way in DevOps and how agentic AI can help you, what to be afraid of.
Yeah. It's I'm very proud of our latest episode with Laura Taco. We break down and look at actual data of people they're using AI for development in all of its forms, and what is the actual business productivity gains, and they're a lot lower than the CEOs of AI companies tell you. So she's got a lot of nitty-gritty details from hundreds of organizations, big and small, and we go through it for like an hour and a half. We go through all the details of why, what's hard, what's not, like what are people good at, what's happening, how are people implementing AI in the enterprise, and specifically around development. Like, this is a development-focused podcast. It's all about DevOps. So we're focused on solving DevOps problems with AI, and not just the hype, but actually like the real people on the ground. So I'm excited about it. I also want like 10 more episodes. But we all have other jobs.
Let me catch up. I'm too behind, but let me catch up.
The LoRa, you skip ahead to the LoRa one. I think the one you might have to skip if you're too behind is my rant about favorite AI terminals or something. Well, thanks so much, people, for being here. Eric, thank you so much for 2 weeks of effort and work to get this done. If you're a subscriber to this channel, we will probably be editing this down so that it's a shorter version for people. If you're on my newsletter and stuff, you'll hear about that maybe, as well as all the releases. We put those out on the newsletter. You can find all that over there. My newsletter is very low frequency. It's like once a week at most, and it talks about what I'm creating and all these videos we're making. So if you're into containers, if you're into Kubernetes and DevOps and stuff like that, this is the place. And we will see you maybe tomorrow on the live stream, maybe next week on the live stream. Whenever you want to hang out with us, come back. We'll see you soon. Thanks, Eric.
Thank you.
See y'all.